Hello everyone, good evening and welcome to my channel Aptitude Club. Today in this video we are going to discuss this question on series and specifically these kind of series questions belong to the topic Arithmetico-Geometric Progression. So it's like a combination of arithmetic progression as well as geometric progression. So sometimes we can see application of series in this form and this is a specific way to solve these kind of questions. Now we'll try and discuss in what manner you should approach such kind of questions when you see next something like this, and then try and approach this. Okay, so let's try and see, and as always I'll try and suggest to pause the question at this moment and then try this yourself first. Okay, try yourself, if you know some method of solving this, and then look at the explanation, you will definitely understand it better. So let's begin. Now before solving this, let's try and figure out what kind of a pattern here we have. This 1 I can basically write as 1 x to the power 0. So we can see this x to the power 0, x to the power 1, x square, x cube and so on. This thing is in geometric progression. But are the constants 1, 4, 9, then 16, are these constants in arithmetic progression? No. Directly as of now they are not in arithmetic progression. But is there any pattern to them? Obviously they are going in squares. These are square numbers. So when you have square numbers, if I take the difference 1 and 4, the difference is 3, 4 and 9 it is 5, 9 and 6 it is 7, 6 and 25 this is 9, and then this is 11, and I can see that difference is in arithmetic progression. Although the constants or the coefficients are not directly in arithmetic progression, but their difference is in arithmetic progression. So when you see such a pattern, first we need to understand that what kind of the pattern the coefficients are in, and accordingly we'll decide our approach. So I'll solve this question. I'll also give you a question towards the end of the video to try yourself, and do let me know the answer of that in the comment section. So let us see. So here S is given as 1 plus 4x plus 9x square plus 16x cube plus 25x to the power 4. Let me write another term, 36x to the power 5, and so on. This goes on till infinite. So what I'll be doing is I'll multiply x throughout. So to this sum s I will multiply x. That means x is going to be multiplied to all the terms in the series now. So x into 1 will be x. So I'll write it below 4x. Just write the corresponding variables below each other. So when you are getting x, write it below x. Then 4x into x will be 4x square. So I'll write it below 9x square. Let me just leave one place and then write. So that subtraction or addition, whatever computation you are going to do next, will be easier for you to understand. Then x into 9x square is 9x cube. Similarly 16x cube into x is 16x to the power 4, and then 25x to the power 5, and so on till infinity. So you get these two series. Now what you do is subtract. So LHS would look like this. So s minus this thing, just subtract. So s minus x into s, so s common 1 minus x. I'll have 1 here. 4x minus x, I'll have 3x. 9x square minus 4x square, I'll have 5x square. 16x cube minus 9x cube, you have 7x cube. 25x to the power 4 minus 16x to the power 4, you have 9x to the power 4. Similarly 11x to the power 5, and so on till infinity. We get this result. Now let's try and see what happened. Now if you go back, look at these numbers 3, 5, 7, 9, 11. These are the differences of the coefficients. Now because I saw okay the difference is in arithmetic progression, so first I need to bring the series to that form. So I needed these numbers 3, 5, 7 and 11. So that is why you multiply x and subtract it once. So I got these numbers 3, 5, 7 and 11. Now I can say 1, 3, 5, 7, 9, 11. This is in arithmetic progression. X to the power 0, x to the power 1, x square, x cube, and this is in geometric progression. But still there is no formula to solve this. But I can see If I'm taking this 1, then 3, 5, and then 5, 7, 7, 9, 9, 11, there's a constant difference of 2. So objective is, when you multiply x and subtract, what happens basically? The process, so I'll tell. Just don't try to remember it in something of a mug up type of a thing. Don't try and look at it in that. To try and understand the logic of it. If we are doing it in this way, why are we doing it in this way? So what happens when you multiply x and subtract? So I did this. I multiplied x and subtracted. So I basically got the coefficients as their first difference. If I can do it again, so repeat the process till the coefficients are same. That means you remove the arithmetic part. So look at this. First, when I had the coefficients 3, 5, 7. So when I did it once, I got the coefficients as 3, 5, 7. Now I'm seeing the difference is 2, 2, 2. That means if I'll repeat this process again, I'll get 2, 2, 2 in every coefficient. And once the coefficients are same, so I'll only deal with a GP and there is no longer an AP. So whenever you have a question like this, the objective is to remove the arithmetic progression part and just convert it to a simple GP. And then we know how to apply the formula for GP. Let's try and see. So we'll continue from this step. 1 minus x into s. Let me write it in this slide. 1 minus x whole into s. This is like 1 plus 3x plus 5x square plus 7x cube plus 9x to the power 4, and this goes on till infinity. Again multiply x throughout. So 1 minus x into s whole into x. So 1 into x will be x. I'll write it below 3x. Then 3x into x is 3x square. Then 5x into x is 5x cube. Similarly 7x to the power 4 and so on till infinity. Look what happens when you subtract. So 1 minus x into s, 1 minus x into s, I can take common. From the first I have 1 and from the second I have x. This is equal to 1. Then 3x minus x is 2x. 5x square minus 3x square is 2x square. Now see, I got the difference 2 as my coefficient. So 2x cube, 2x to the power 4. So this is like a simple GP. And this is an infinite GP. So you get 1 minus x into sec to the power 2 square. This is 1 plus. This thing is an infinite GP. So infinite GP, what is the sum of an infinite GP? Sum is obtained like this: a by 1 minus r. A is the first term and r is the common ratio. So in this infinite GP, the first term is 2x and the common ratio is x. So I get 1 minus x whole square into s. 1 minus x I can take as LCM. So 1 minus x plus 2x. This gives me 1 plus x by 1 minus x. Or if I solve it a little further, 1 minus x whole square into s is 1 plus x by 1 minus x. Or s I get as 1 plus x by 1 minus x whole cube. This is actually our answer. But question specifically has given me a value of x. Calculate the sum for x equal to 1 by 4. Now substitute x equal to 1 by 4. At x is equal to 1 by 4, s will be 1 plus 1 by 4 divided by 1 minus 1 by 4 whole cube. So this is like 5 by 4, then 3 by 4 cube. So I get 5 into 64 divided by 4 into 27. So we get 80 by 27. That is the answer. I hope all of you got an idea how to solve this. So the logic lies here. Whenever you see the coefficients, look what the pattern is. So I can see, okay, in this kind of a series, The first difference is in arithmetic progression, and their second difference is constant. So I did this process twice. I multiplied x and subtracted, then I did it again. Why did I do it two times? Because the second difference was constant. So until I do it two times, I will not get the coefficients as constant. So the objective is always to remove the arithmetic part, bring it to the geometric progression only, and then apply the formula and then solve. So the answer to this is 80 by 27. Hope all of you got an idea how to solve this. So I've given you a similar question to try. 1, 8, 27, 64, 21, 25. So if you look at the coefficients, 1, 8, 27. So these are the cubes of natural numbers. So when you take their first difference, sorry, this is 19. 27 and 64, this is 37, and then this is 61. When you take the second difference, this is 12, this is 18, this is 24, and when you take their third difference, that is constant. So that means that process, multiplying x and subtracting the series, has to be done 3 times, as third difference is constant. So you guys can try this question yourself first and then solve it for x equal to 1 by 3. Let me know the answer in the comment section. If you have understood the process, you will be like finding this very convenient to solve. Just you have to do it 3 times. Alright. So that is it from my end for this session. I hope all of you enjoyed the explanation and learned something about arithmetico-geometric progression. We'll do more questions like this in the future. Till then, keep solving, keep watching, and if you're new to the channel, don't forget to subscribe the Aptitude Club channel and explore the previous videos that I've done on this QA booster playlist. I have linked it in the I section. You can check out the previous videos. To check out the LRDI sessions also that I've done, you'll definitely find them useful and insightful. We'll meet again very soon on yet another video. Till then, bye bye and thanks for watching the video.